Well, hi, good morning. Thank you so much for joining me in my shop. Today is July 24th. The weather forecast here is very hot weather, maybe 35. That's very hot here, followed by a thunderstorm in the afternoon. Of course, those things kind of come together. So, yesterday I sort of thought my way through this and decided, well, okay, the sensible thing to do is to deal with the hum by augmenting the supply capacitor here, the power supply capacitor. I can either kind of replace that capacitor by removing it from the circuit, or I can just augment it. I think I'm just going to augment it, and we'll see what happens from there. As I explained earlier, it puts the rectifier here at a little bit of risk. Probably not much risk. In my shop, no risk because I restrict the power all the time. But in regular use, wham, you know, the nuclear plant, pow. Okay. And I also was considering replacing this or doing something about this. This resistor is supposed to be 2,000 ohms. It's 2,500. And that's probably the cause of the low voltage through the heater string. And I do have lots of large wattage resistors. I have to go through them and try to find one that's 2,000 ohms. And so those two things should sort out the situation. What am I talking about? What am I saying? You know what happened there? I ran out of things to say, but I just kept talking. Okay. If I would start talking with nothing useful to say, I could have been a politician. Okay, enough of that. I actually have a lot of respect for politicians. You know, it's an ugly job. Thank God somebody does it. A job that's being made worse all the time by people who just aren't thinking at all, and just ruining the lives of politicians. And you know what's going to happen. You're always going to want to be a politician, except certain people. Okay, I'm going to fit in capacitors here. Maybe we should just take a look at the schematic. There's a couple of different sizes in here, and sorting out which is which size is a little bit tricky. Let's take a look at the schematic. Okay, now in this schematic, these capacitors are kind of scattered around. So here's an 80. Here's another 80. This is that 25. This is 150. And then I think I saw one up. Here's a 40. And here's another 40 over here. And that pretty much covers it. Oh, look at this. They've put the symbols. The square and the triangle and the half moon here are symbols you would find marked right on the capacitor to help figure out which lead is which. So that would be helpful. But 80, 80, 40. So what happens if I do 80, 80, 80, 40 over here? What if I did? What if I just added another 50 onto every one of these? Wow, it sounds like a lot of capacitance, doesn't it? So looking at this one again, this is the 82 ohm resistor here, 2 watt that's going to restrict power flow through the diode while these capacitors are charging. Probably not really a concern, blowing this up. And I may replace this anyway at some point, going down the road. Okay, I will use these symbols. Well, let me look at the radio here and just see. Usually these symbols are hidden from view. When the capacitor is installed, the symbols get blocked from view. And I think that's the case now too. So the symbols may not be so helpful. Okay, but I can study the schematic and figure out from wires going places which terminal is what. And but I did say I was just going to put a 50, 50, 50, 50 on this. So why do we even care? I don't even care. My assistant has shown up here. So here's the replacement capacitors. I'm just putting them together in a little bundle. I'm about to solder all the negatives together here. Just watch out. Hot soldering iron here, cat. So I got the 4 positive leads and the 1 negative one in the middle. It's not quite appropriate, so now I'm going to fit this on here. Can't have it sticking out. It's got to be under the edge here. Okay, so I'm going to work that in. Right, Bert. Bert knows his name. At least he knows when if I yell out Bert, he turns to see what's going on. Thank you for the view. Appreciate that. Close that down, would you? Okay, well, somehow I've managed to get all those in there without too much trouble, actually. And they're just clearing the just clearing. Very good. You can see all the grounds. You can see all the positives. Nothing's touching anything. Everything is soldered. Okay. Ready for a test? Toffee first. Okay, my expectations here. I don't expect this to have worked. I expect the radio to behave exactly as it did before, with the same hum coming through it. And why is that? Because I'm pretty sure this radio did not hum when I first tried it. I could be mistaken about that, but I'm pretty sure. It only hummed after I changed this IF transformer. Why that would be the case, I don't know. I don't know. So, okay, with very low expectations. Turn the volume down. We're going to turn the starting voltage down. And anything else? We want to turn down our hopes. I do have the extra antenna booster going. Okay, I don't see any reason not to continue. So I've worked right on the power supply here with these capacitors, so very important to use the dim bulbs at the start up here in case I've made a mistake, because guess what, I make mistakes with some regularity. Here we go. Okay, it's going to come on. .91 volts on it. You'll hear a thing. Well, I think my guess was right. It's no different. Is it? I don't think it's any different. Okay, had to do this to eliminate possibilities. And probably worth doing anyway. Let's try a little band change. See, there's just nothing. Nothing like there should be a click and a pop and stuff like that. Wow, phooey. Okay. Right. So I've convinced myself I have this installed correctly. I've done it very carefully, made out a diagram here based on what I'm seeing in the radio, and then I compared this diagram to the schematic. Everything worked out properly. I have reversed the leads on the primary side. It made no difference this way or that. I'm not too surprised by that. We have this is very low now. If this is low, and if this is dropping too much here, and we're not getting the right voltage, how low is it? because there could be more going on in the heater string, and there could be you know, a tube that is starved for its voltage. Maybe. Okay, so we're going to look at the voltage on the start of the heater string. So we put one on the B minus, which is right here, and .1. Isn't that totally wrong? Sorry, my hand's right in the way here. Oh, what scared me there? Okay, the starting voltage. Oh my gosh. Get on there and stay on there. The input voltage to the resistor, 88. The output voltage from the other side, 5. 88 sounds low, probably because of the 91. The real voltage we're looking for up there is 9, if I remember right. 9 volts. So we're going to raise this up. Now, you know what? In the hum has come back stronger, more like I remember it. So we're going up around 110, let's say. Okay, 110 volts. Now we look at the input voltage to the heater string, which I think is right here. 6.8, supposed to be 9. Way low. And we know that this guy's dropping too much because his resistance has gone high. We can do this. We can do this. And make that to 104. And we can do this. I see 97. There it is. All of it dropping here. Of course, that's what has to happen. Hum related? I don't think so. How come we're not hearing any radio stuff at all? How can this be the case? We'll try a couple different bands. And the volume up. And there's that darn hum. The buzzy hum. Buzzy hum. What I want to do here is attach the antenna, the outdoor antenna, onto, ooh, that scared me, onto here. Make some noise there. And then the ground, I don't know that we really need to connect it. Okay, back to broadcast band. Oh, now we're hearing. That's interesting. That antenna attached, we hear this band change. Okay, so I am in the broadcast band. This is the I'm not hearing anything, of course. What do you expect here? Now, so we go 1, 2, 3. So we're in some high frequency band now. Still, it's just a hum. Just a hum. Hop, 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 hop. She's a hummer. It's a bummer. Can I be any dumber? Oh, that's pretty bad poetry there. Well, yeah, what's next? What's next on this? How, you know, so the hum can be coming. 3 through the power supply. But that's not likely now that I put all these capacitors on there. It's not likely at all. So the hum is being introduced another way. It sounds to me like the kind of thing you get when you have an open grid circuit and the feed to the grid of the tube is open circuited. It becomes an antenna. A little antenna in the radio. There's lots of stuff to pick up. That's what it sounds like to me. Like some grid has not got a connection. And we try to tie that back to the IF transformer. One lead does go to a grid. I'm pretty sure it's this red one here. But you know, I can't make that story go any further because I can't find any open wires. Open wires. Okay, I'm gonna go drink some coffee because it's cooled down by now. Hey, maybe we should check the weather. Let's check the weather here. I don't know how they could be forecasting rain. I live right here, and there's nothing near at all. I mean, this may eventually get over here, but nothing imminent, that's for sure. Good. Okay, if you hear a bit of a roar, that's my house air conditioner running. So let's take a look at the schematic here. What I'm thinking of doing is listening to the signal right on this blue wire. So this is the transformer I replaced, and the blue wire basically should have the entire antenna signal on it and the local oscillator signal and the products of those things, which would be either 450 kilohertz above or below incoming signal. So it's a whole pile of stuff on this wire, and we could look at it on an SDR. If I can figure out how to safely connect an SDR to it, I'll put the scope on it. That's not going to help much. Or I can listen to it with my signal tracer radio receiver, which I could hook up here, and then I can tune the radio receiver, and we can hear what kind of stuff is making it all the way to here. And that is dependent upon the tuning of the radio, and certainly which band we've selected out here. So I'd want to be on the broadcast band, aim for a strong station like 590 here from Toronto, and try to hear it using basically an alternate radio hooked up right at this point. That's basically what's happening. So we ignore the radio itself and insert a new radio right here. And I certainly know where this is, the blue wire. Okay, that sounds like a plan. Good. Okay, I don't know. Can you hear a bit of a hum? It's coming from this guy here, who I've just turned on. So we want this to work as a radio receiver on the broadcast band. So to do that, we need to use band B. That's band B. And this has to be set to RF, which it is. This is now a radio. Let's see if we can pick anything up here. 590. What's with the hum? That's kind of weird. What's happening there? There we are. That's a little better. Where's the radio stations? Hey, what's going on? Oh, something not right here. What's happened to you? Okay. 590. Why so weak? This should be coming through loud and clear. This is a little disturbing. I'm not sure I can go forward with. Well, I don't know what it is. Seems awfully weak. Maybe it's because I have the antenna shorted out with the clip lead. Yeah, that's what it was. Okay. French station. Not sure what that is. 740. Wow, there's quite a strange hummy thing there. This thing, I'm not familiar with hearing that in here. And it's just in this part of the band. Well, we can run this at any frequency we want. Let's do it on the French. Okay. French station. Now the idea is for that signal of the French station to be picked up more directly from here. I'm going to put this on here. Okay. So this is the blue wire connection that's coming from the plate of the mixer tube. So on this wire should be everything. Everything should be on here. Should be able to tune through and find the same stations. Now, they may be weakened a fair bit, I have to admit. But let's experiment. Let's experiment. Let's see what happens here. Maybe I should keep this off to start. Off to start. Here we go. And the radio's on. And there she is, humming away. Okay, I'm going to turn the volume down on the radio so we don't hear it so much, but just enough so I'm aware of it. Over here, volume down. Connect this. Okay. Volume up. Now this radio has to be tuned close to the station we're listening to. I would expect we'd be hearing stuff already. I can also tune this. No reason why I can't. 850. Tune it. So we're not picking up anything at all. Nothing at all. The local oscillator should be on this wire, and most importantly, a 456 should be on here, if 455, if we tune something in. So let's not quite give up on this yet. Let me tune the radio in the range of where I think 850 might be. Turn this up a bit. We're not hearing anything at all. That's giving me any idea that there's any radio-ness coming through here. Turn this one down again. This is a complete failure here. Right, so we're going to look for the converted signal, 455. So I'm going to change this now to band A, which is this upper band. Okay, and we're going to tune it to around 455, which is right here. From remember right, the IF frequency of the radio was off. It was around 430 or something like that. That would be around in here. Okay, listening to this sound, I'm going to tune the radio. We'll see if this sound changes at all. It does not. Okay, so that's, we're going to go down where it should be. There's nothing here. There's nothing here. The local oscillator's gone. Is that possible? The local oscillator is not oscillating. Is that the possible problem? Ooh, that could be the problem. Your local oscillator with the radio tuned low. Okay, so the radio's tuned around 600. The local oscillator is going to be around 1,000,000. So if we tune the radio now to 1,000,000, we should hear the local oscillator itself. So we'll try that. Okay, we're back on this band, and 1,000,000's down around here. So local oscillator is not modulated, so if we hear it, it's I don't think so. I got a better way of checking this. There is a better way to check this. Okay, I'm gonna do that. We'll shut the radio off and drink a little coffee, and then we're gonna try something that maybe the local oscillator is gone, and that's why the radio's not operating. That would explain a fair bit. Okay, so up at the top of the screen, what you're seeing is the results from my SDR. The SDR is using that same loop here, this loop as the antenna. Hello? How come? Yeah, there's a bit of a change there. Yeah. Okay, so this is going to pick up. I'm going to leave it here. We can whip it around like this. This could pick up the local oscillator, or should pick up the local oscillator. It should pick it up down in this, all over the place, really. You can put it there. Now, it's possible I didn't have this on the right band. I think I've got it on broadcast, and I don't. I know I didn't at the end there for sure. So I believe this is broadcast, I believe. We will find out. So the radio is tuned to the low end of the band, maybe around 600. So again, around 1,000,000 is where the local oscillator should show up. So if we're looking up here on the screen, somewhere right in this area here is where it should show up. Maybe a little higher, maybe up in this area. Okay, power on the radio. Any reason not to? I don't think so. Here we go. You see a whole bunch more stuff showed up on the SDR. If you look at the waterfall display, you can see just a whole pile of additional stuff showed up. Now, is there anything really distinct in and around here? You didn't see anything like it should be the strongest signal out there. Now, it could be I have this coil in a bad spot. So I'm going to tune the radio a little bit. I'm going to watch for one of these signals to move around, but chances are all of them are going to move around. In fact, maybe I'm going to no, I'll let you watch what I'm doing here. So here we go. We're tuning. So there is one moving, one right in the middle there. So I'm pretty sure this is the local oscillator right here. So if that were the case, and we wanted to tune in 590, we don't know what the IF is tuned to. We don't even know it's really tuned at all anymore. Last time it was somewhere around 430 kilohertz. What I was going to do is set the local oscillator and then know the radio will receive a certain station, but I don't think I can do that because I don't know the IF frequency, and frankly I'm not sure anything's getting through the IF. So local oscillator appears to be there. Let's go up on a higher frequency to I'm on this band. So this is up around 8 megahertz at the top. Let's go higher yet. Oops, wrong way. There's that funny ring that goes up and down in pitch. It's very odd. So now we're somewhere up up in one of these bands here. Let's go right to the top. I decalibrated myself here. Okay, we're at the top. Top would be this band. Next one down. There. Okay. 14 megahertz. 15 in the middle. 15 megahertz in the middle. Okay, well, I'm going to change the SDR now to match that range. So 15 megahertz is right here, and the local oscillator should be just nearby. Now it could be above or it could be below. I'm going to tune the radio a bit. You watch. Oops, that's not tuning it. So see, lots of things are moving here. I'm gonna guess this is the local oscillator here, and that's probably making good sense because I think we're tuned around 15. Why do I think that? I don't know. No good reason. Let me just. We're tuned around 14.7. But again, no idea of the alignment of this radio. But if it were 14.7, then you would expect the local oscillator to be 400 away, 450 away. Doesn't quite make sense, but once again, it certainly appears to have a local oscillator in it. Let's come down another band here. Wrong way. Okay, I sort of lost track of where we are on here. Okay. 1, 2. That's really slippy. 2 down on the band. 2 down on the band puts us on 17 megahertz. So we take this up to 17. A little higher. Oop. Okay, so 17 is somewhere in here. There should be a local oscillator. That's probably it there. And I'm going to tune the radio and see if it moves. Does not move. Oh, this is moving. This it's a little weak right here. Now it could be weak just because of where I have the pickup coil. But again, this really does prove there is a local oscillator operating in there. Let's go down to the broadcast band and judge its strength, which is not. Okay, so this is the broadcast band, I believe. Am I doing this right? You're doing this right. I think I'm doing this right. Yeah. Broadcast band. Just in case it starts picking stuff up. So you can see even when I'm on the broadcast band, what is this? Is that moving around? Huh. Wow. So it would appear that even when the local oscillator is supposed to be generating a frequency around 1 megahertz, the radio is producing frequencies up here almost 18 megahertz and probably all the way through. Harmonics, many harmonics, probably. Let's go down to the broadcast band. I don't know if anybody can even follow what I'm doing here, but so big strong guy right here. Tune the radio a bit. That's not it. Oh, where is the where's the local oscillator here? So maybe I haven't got the broadcast band on. Don't see how that can be the case. Okay, this won't go any further. So we're on the all yellow. Next one over. Oh, no, it did go one more. Okay. look at this. Look at that, Jim. That's broadcast. See those 3 trimmers there, Jim? That's broadcast when it looks like that. Did we get? Oh yeah, now we got all kinds of stuff on the screen here. One of which is going to be the local oscillator. And they're all on the move. Almost all of them. Except, oddly enough, there's weird, like when I'm doing this, I get weird symmetrical patterns on here. All kinds of strange stuff goes on inside these radios that you can't normally hear, because the only thing that comes out of the speaker, if everything's working right, is frequencies at the IF frequency, which would be 455 if everything were normal. All the other junk that's going on, you can't hear it. You won't never know it's there, but it appears to me, when I keep using the SDR to do this kind of stuff, and just use a pickup coil and pick up signals, there's all kinds of stuff running around inside these radios. So, I mean, this one's kind of interesting. It looks like the same, it looks like a harmonic repeating over and over and over, same space all the way across. And is that coming from the radio? Well, that's a good question too, so let's turn it off and see what happens. Some of them go away, but not all of them. Wait a minute. This one didn't go away, but it's in exactly the same pattern as the rest. That's really, really bizarre. How would you explain that? I mean, look at how uniform these lines are down here. I can do that again. Turn off the radio. Three remain. Wow, I don't know. No, this one you can't do anything now. Wow, okay, let's turn it back on. That's just that's a freaking mystery. That's what that is. Yeah. Wow. Wow, I don't even want to think more about it. Okay, so local oscillator though. We're trying to spot the local oscillator here. So what I'm going to do? Oh, look at this. So if I move these like this, now they don't look like that pattern. It doesn't look uniform across the bottom, right? So I just happen to have tuned the radio in such a way that come on, that just really, that all those lines were equidistant on the waterfall display. That's even weirder. That's even weirder. Let's put this in a better location where it has a chance of picking up the local oscillator all by its lonesome, or at least more so. Maybe in here. I think it would be up in here. No. The other way. I keep thinking, I got this radio backwards in my head. It'd be here. This would be the good spot. Down in here somewhere. There's a shield missing on this tube. Wow. Could that be the cause of the hum? Oh my gosh, I don't know about that. That's an interesting question. One of these is driving the local oscillator. So there's a lot of local oscillator stuff here, for sure. And we'll tune the radio a little bit. It's still got everybody and his cousin moving around on there. Look at this. All these are, as I tune the radio, I reach the limit of the radio's tuning. It's all heading for those three things. Let me go the other way. What was that? That was the pointer getting caught on something.
So again, there's a spot that's equidistant. Something to do with a 60 cycle hum? No, how can it be? I'm tuning across here. This is just weird. I mean, really weird. Ah. Yeah. Why am I not seeing the local oscillator nice and clearly? Like every other radio I've done this with, it's really easy to spot which one of these peaks is the local oscillator. I'm tuning down. The local oscillator should be going down. I think it's this one, but I don't know for sure. I don't know. Is it possible to get all this without the local oscillator operating? Is there a better way for me to see the output of the oscillator? The oscillator tube is probably this one with the shield on it. I don't know that for sure, but we could. And tune the radio. Still, it's just like I'd like it if one of those really stood out. They don't. I'm not getting the good feeling. Okay, coffee time. Whew, just came back in from outside. It's 11 o'clock in the morning here. It's 31 degrees outside. Can't stand being in the sun already. It's very humid. Wow. And it's only 11. So I think I'm going to call it quits here for today at this point, and carry on with a little bit of outside work before it gets so hot we can't be out there. So thanks a lot for watching to this point. No idea what's wrong with this radio.